Today's video is going to be about files in Java and how we can read information out of a file and how we can write information back to that file. I suppose it's prudent to start with an explanation of why we have files, why they're useful to us. So generally, you use a file to store information that you need to retain beyond the lifetime of your program as it runs. So up to this point, we've kind of just been making some variables, doing some math, outputting a result, that sort of thing. But we've not had an occasion yet to remember data beyond the duration of that program running. When the program runs, it stores all of the variables and all the information into the RAM, the random access memory of the computer, which is a temporary place. And as soon as the program's done, it unloads from memory and it goes away, so it's lost. So what kind of things might you want to store when your program's over? Well, you might want to make a program that requires the user to enter credentials to get in. So it might need to store usernames and passwords. It might just want to retain some settings like did you want to have a certain access level, or do you want to remember to turn sound on or off in your game, that kind of thing. So the next time you load it remembers that. High scores is a very common one, like you just want to know the top 5 people who had the highest scores in the game so far, along with their scores, store their names, that kind of thing. As well as maybe you're in a chess game, it's pretty long, and you want to just exit but save the state of your game and then load it back up later when you're available to play it again. That could go for really any game. Uh, but programs like Word and Excel and PowerPoint, those things store all of the things you've created. When you hit the save button, that's stored on your hard drive or wherever you decide. It could be a USB key, but it's going to be stored somewhere permanently. This is a file that gets created with a .doc or .xls or .ppt extension, indicating to the operating system what type of file and what program should load that file when you double click it from Internet Explorer. But even your Java programs, the source code is just plain text. That's just something you would save and then load up later so you can edit it and add to it or change it, right? Just so you have it. So what's the difference between an ASCII file or a binary file? ASCII stands for American Standard Code for Information Interchange, and that's just a code system, a table that stores codes for each letter and symbol that we have in any language, right? So, well, I mean, I guess the American standard is the American version of that. That's kind of like now been replaced with Unicode, which is a universal code for all characters. So, the difference is that for binary files, they're not just text. So if we're talking about a text file, we're talking about something that's just letters and numbers, but not coded information. So let's just say that it would be something that you could open up in Notepad and read it. So whereas other examples of something that would be a binary file would be something like a compile.class Java file. So it's been compiled in bytecode. We can't read it as humans anymore. If you open it in Notepad, it would look like gibberish. Music files like MP3 or WAV files, those are binary files because they're not text at all. They're a bunch of ones and zeros representing music, like sound waves and that information, and it gets decoded and processed by some program. Same with image files and video files, and even Microsoft Word documents, although you might think that's plain text, it's not, because those are binary files, because you would have, as well as the text, you would have it marked up in a certain way to be bold or italic or underlined or different colors and fonts. So all that information is bundled into a binary file, and when you launch it in Word, it knows how to render that on the screen so it looks the way it needs to look. And that's all through codes that are embedded in there that the program knows what to do with. So that's the difference between binary and ASCII files. And we're just going to deal with text, plain old text or ASCII files in this course because they're just the easiest to deal with. So there is a file class in Java, and that is a very handy class that allows you to do a few key tasks. So it's a bit confusing at first because it's called the file class, but you can make a file with a given string, as is kind of indicated here, but you don't actually, the file doesn't actually exist yet. It's just in memory, it stores a name that you want to name it. It doesn't exist until you either, it's a file that's already there and you connect this file object to it, or if it's not there, you can run this create new file method that will actually make a file with the given name in the given location. So that's what the second method here. This is just a constructor, and I'll show you some code examples. A couple more methods that are handy. If you want to delete a file, this is a very dangerous one. You could write a program that deletes files from somebody's hard drive, which would be malicious and not advised, of course, by Mr. Venom. But no, in all seriousness, I've made programs that do delete files if I want to mass delete something. You could use this. You just have to be careful not to delete the wrong things. But you have to provide a file name. And if I want to clear out a directory where I've collected a bunch of student assignments, I can just run the delete command in a loop and delete everything. So exists is pretty handy. You can just tell whether the file's already in existence. Like if it's a high score file, maybe the first time you run the game, it doesn't exist. But once you've played it once, it creates the file, has some high score information in there. And the second time you run it, you can say, oh, it already exists. I don't want to recreate it from scratch. I want to look at what's in there and determine whether my current player has exceeded the high score in the file, and then I'll add them. So here's an example of just checking for the existence of a file. Now you can see that here I'm saying c:\supplies.txt. txt is a typical extension for a text file, plain text file that you could open in Notepad. So, and this file is in the root of my C drive. So here I'm specifying a file path, which means what directory is it in? Most of the time, all my other examples will omit this file path part of it because I'll just store them in the default location. It's just easier, and I'll tell you where that location is in Eclipse. So yeah, just like making anything else, you say the class name, the object name you want to give it, which is up to you, equals new, and this is the constructor name, as on the last slide. You saw that it took a string, which is the name of the file, really, and optionally the file path of where to find it. So you construct this thing, and then once the object exists, you can say, does a file on my hard drive exist with this given name? And if it does, it'll say already exists, and else it'll say no, it does not exist. So you can perhaps create it at that point. Now, this brings up the very important topic of handling errors or exceptions. They're called exceptions in Java, but they're just errors. To handle an error, you can use this try catch finally block. And what it means is basically try to do this thing, like, for example, connecting to a file and writing to it. And if something happens, something goes wrong, catch the exception and carry on without crashing in a very ugly way, like error messages in red popping up all over the screen, right? So some things when you might have to handle an exception if you're trying to write to a file that's not there or read from a file that doesn't exist. Those would be examples of where there's potential. Maybe somebody moves the file that you're trying to read from, and it could just completely crash your program. So it's better just to say, hey, that file no longer exists there, it doesn't exist. and the user's informed nicely about what happened, why the program stopped. So here's that example. I'm going to make the thing, make the file object, which doesn't guarantee that it exists yet. Then I can check if it exists and put out this message, already exists. And otherwise, I can try to create a new file. So I'm going to do a try block here. In between these curly brackets, I'm going to try and create the new file, and then say new file created. If it can't create it, like say there is no such directory, or for some other reason, like there's not a C drive, something like this, then it'll just say file could not be created, and it'll, you can see here actually the parameter in this block here is E, that's the object's name. I can just say e.getMessage, and it'll print out some computery compiler official message. So, but for the layman, we're just going to say file could not be created. There are different types of exceptions: file not found, number format exception. This one's input-output exception. So there are a number of different types that you can look for and catch, or if you don't know, you can just catch a general exception object. So here we're going to try and do our first program, look at how we would actually read from a text file. So you don't really have to separate a separate string for the path or for the name of the file, but here it does. You create the file, which is not going to create an error in any way, but here we're going to use the scanner class. So scanner class we already know. We already know how to use it for the keyboard and typing in input. It's the exact same thing if we're reading from a file, the same commands, but the process is actually it's going to connect to a file that exists on your hard drive rather than read keystrokes off the keyboard. So here it's the same constructor as before, but instead of system.in here, we're going to put file, which is the name of my file object that I constructed earlier. Now, if it doesn't exist and can't be found, that's going to throw an error. So that's why we're trying to do this. If it works, great. If not, we're going to catch that error, and it's a file not found exception, and we're just going to say cannot open, and it'll indicate what the file name is to the user, and then it's going to quit because there's no point in going on potentially here because we're just, we need that file, so we're just going to exit. So here's some of the scanner methods. We already know most of these, but we haven't really used has next line. That's going to be very important for just looking ahead in a file and seeing if it has another line in there, and it's going to return a Boolean like true or false. If it does have another line, it's going to return true. If not, false. Same with has next. Just the difference between next line and next is the same as before. Next line is going to look for the enter key, like multiple words until it sees an enter key. This is just going to look for one word, like one token separated by a space. You can also look for integers and doubles, like does it have another integer or another double stored in the file. And yeah, you can close the scanner at the end. Here is reading in a loop. So here we're just going to make the file, the scanner, and we're going to, if it does work and we don't exit, then it's going to, in a loop, a while loop, because we don't know when it's going to end. We don't know how many lines there are, so we're just going to say input, which is our scanner connected to the file. If it has a next line, then we're going to read that next line from the input stream, store it in a string called line, and just for confirmation, we're going to print it. Now, let's just take a look. Probably it makes sense to take a look at Eclipse now. So we're going to take a look at, well, okay, so let's first of all take a look at the first one. This one is just looking, using the file class. Here's looking for a file. So just to show how, if I don't specify a file path, where should I put this file? So you can see I have some files here in my file tester project here, I have files, high score, output, and words. So you can kind of see they're not in the source directory because they're not source files, they're not .java files, they're text files. So if you had one, let's say I'm just going to make one in Notepad here, and I'm just going to make, A, B, C. This is my Notepad file. If I file, save that, I can save it to downloads. I'm going to call it test txt. Well, it's already got that file extension, but it already exists. Okay, we'll overwrite it. So I can either create it in Notepad and I can drag and drop it. If I'm going to drag and drop it in from downloads, I'm going to go to downloads and very bottom, I guess. Oh wow, I got a lot of downloads. Got to clean up. So here it is. So I could drag and drop this thing, drag it, and I'm going to drop it on the actual project name itself, not in source or default package, just right there. And that'll copy it in. So there it is. There's a text file. I can even look at it in Eclipse. It'll be able to open a text file, obviously, because these are just text files too. So right now it should give me an error here. If I try and find abc.txt, it should say can't find it, doesn't exist because I don't see it here, right? So if I run this thing, it says that, since it didn't find it, it tried to create a new file. So it took the text file, ABC, that name, and it ran the create new file, and it told me new file in quotation marks, whatever and I can run a get file name or get name, sorry, that asks for the name of this thing I made earlier, so I don't have to hard code it or retype it. And it says it created it. If it had some reason why it couldn't, it would just do this. I don't actually see it here, which is a little annoying because I probably have to refresh this. There we go. Now I refresh it and there's ABC. It'll just be empty. There's nothing in it, right? So I can close that. Yeah, so that's kind of just the basics of connecting to a file only. Let's take a look at how to read from a file. So here's my example that I showed you on the Google slide. So here we go. So we got words.txt. That exists. Great. I don't know what's in it, so let's see. I'm just going to do a loop while it has another line. It's just going to read that line, and it's going to print that line. So let's see. If I run this one, we'll see what's in that file. So it's just giving me a quick message first that words.txt exists because I ran that first. Up here it says it exists, and then it's printing the contents of the file. So if I want to double check, I can look at words.txt. There it is. It's got cat, dog, frog, hog, hamster. There we go. Good list of words. And let's close that back up. So that's a while loop while it has a next line. While that's true, keep looping and printing what's in the file just to confirm. So what about writing text to a file? So if I want to write text, it's not too bad either. It's pretty familiar. Again, I'm going to make the file. I'm going to make this object called a print writer. Initially, I'm just going to set it to null, which means the object doesn't exist. I'm going to try, as I said before, try to do something, which is to connect to the file. It may not be able to connect to the file if it doesn't exist, right? So I'm going to try to connect my print writer through the constructor here, feeding it a file object. If it works, great. If not, it's just going to say, can't do it, can't get there, and it's going to exit because there's no point in going further. By the time it gets to here, if it didn't exit, it's going to do a print line. Now that's really familiar, just like system.out.println. And you can either print or println. If you want to go to a new line, And you can even do a printf. So to demonstrate the printf, maybe I should also demonstrate print here. So I could say output print. I'm just gonna say hello. So it should say hello, and then it should say hello again, hit a new line, and then if you remember from earlier lectures, we talked about how to run the printf, which is to make columns or in some way format information to be printed. So here I'm just going to, negative sign means left justify with 10 spaces, a string. The string is going to be item. I just made the item caret. And then it's going to do 0.2f, means f for floating point. This is a floating point number. It's a decimal number. I'm going to round it to 2 decimal places. So this should round to 4.00. And it should print that to a file rather than the screen. So the other thing too, I'm going to remind you that you need to close the file or else it will not work. So if you don't do this closing of your output stream, your print writer, then you'll look at the file and it won't have written that. It won't have finalized that. It's kind of like hitting the send button on an email. Like it doesn't finalize, it doesn't send it out until you hit that. Okay, so let's run this thing and run it. I don't really print anything out, so we don't, but the program has run. Let's go check output.txt. Okay, so it says hello, hello, because the first one was from the print. This one was from the println. It goes to a new line. It prints caret and rounds 3.9999999 to 4.00. So the printf worked, and print and println. And this is all in a file. I could look at this file in Notepad. I don't have to look at it through Eclipse, but there it is. So that could be used for anything, not just printing caret. It could be printing people's names and their high scores, and then you can read them back in later. Usually you would read things into an array and play around with them while your program's running in an array, which is stored in the RAM. And when you're done your program, you want to save it, write it back to the file, and overwrite what was there before, right? So if I actually run this program again, and I change this to say something else, and this to say cucumber, if that's even how you spell it, yeah. And then we would run this, and it's going to overwrite what was there. So that's either good or bad. It's up to you. Like, so it's written over the data. I've lost what was there before. So if you want to write a program that leaves what was there and just keeps adding to it like a log, then you could do this append mode. So here we're just going to look at a quick, this will be the final one. Everything's the same except we're going to use this writer thing here, and the file writer, we're going to do a constructor that allows us to indicate whether we're going to append or not. Now, append means add to the end. So if you put this to true, it switches it to append mode. If it's false, it just overwrites it every time. So same commands, print line. So I'm just going to say, just to indicate that it's actually working, I'm going to run it with append. I should probably check if it's empty already. Okay, probably not, right? Still got that stuff in it. Yeah, maybe I'll leave it there. I'll leave it. So if I close that and I run this thing, it should, says it's done. It should write the word append. And if I'll just run it twice just to show that each time I run it, it's going to add to the end. So here's output.txt. That was the stuff I had before. Now I'm just running, I ran it once and twice, and it just wrote append, and that's really it. That's how you would write data to a file in 2 different ways, and that's how you would also connect to a file and read from the file. So that's really the end, and that's a good start on how to do this. There's some other fancier things you can do, and obviously in your own implementation, you're going to add a lot more functionality, but that's the basics of it.